Gideon L, and for today, we will be going to prove the following trigonometric identities. So, as we all know, there is what we call proving in geometry. But in trigonometry, there is also a proving. However, there is an absence of two-column table. So to start with, we will be going to prove this trigonometric identities. So we should start here. What we should do is to prove that this trigonometric identity is equal to 1. Since 1 minus cosine squared theta is also can be written as sine squared theta over 1, and the cosecant squared theta can also be written as 1 over sine squared theta, and this trigonometric identity is equal to 1. Why? Because we will cancel this and we will cancel this. So 1 over 1 is equal to 1. And 1 is equal to 1. So that proves that this trigonometric identity is equal to 1. Let's move on to the second number that we should prove. So this identity is tan theta times sine theta plus cosine theta is equals to secant theta. So tan theta can be written as sine theta over cosine theta. We should copy this. Sine theta plus cosine theta is equal to secant theta. So we should multiply this. So it should be sine squared theta over, copy the denominator, which is cosine theta, plus cosine theta is equal to secant theta. So we should add this quantity over this quantity. So it can be written as cosine squared theta plus sine squared theta over cosine theta, and it should be equal to secant theta. So cosine squared theta plus sine squared theta is equal to 1. And cosine theta, let us copy that. Cosine theta. So as we all know that 1 over cosine theta is equal to secant theta. And it is true that secant theta is equal to secant theta. So we are done proving that this identity, and this is an identity, that secant theta is equal to secant theta, or tan theta sine theta plus cosine theta is equal to secant theta. Let's proceed to the third number that we should going to prove, which is the quantity minus cosine theta times the quantity of 1 plus cosine theta times the quantity of 1 plus cotangent squared theta should be equal to 1. So as we all know that 1 minus cosine theta times the quantity of 1 plus cosine theta is what we call the difference of two squares, which can be written as 1 minus cosine squared theta. And the 1 plus cotangent squared theta can also be written as cosecant squared theta, and it is equal to 1. So 1 minus cosine squared theta can also be written as sine squared theta over 1. And this quantity can also be written as 1 over sine squared theta. because the cosecant is the reciprocal of the sine. So, it is must equal to 1. And we will do cancellation here like we did on the first number. We will cancel this and we will cancel this. So 1 over 1 is equal to 1 and 1 is equal to 1. We are done proving that this is an identity, that 1 minus cosine theta times the quantity of 1 plus cosine theta times the quantity of 1 plus cotangent squared theta is equal to 1. And that is correct. So next, let us proceed to the second to the last number, which is the number 4. So what's written in here is that cosine theta over 1 minus tan theta plus sine theta over the quantity of 1 minus cotangent theta should be equal to sine theta plus cosine theta. So as we all know that tan theta is equal to sine theta over cosine theta. So we will copy that. Is equal to cosine theta over 1 minus sine theta over cosine theta, because tangent theta is equal to sine theta over cosine theta. On the other hand, cotangent theta is the reciprocal of the tangent. So it is written as cosine theta over sine theta. So let us copy this. Sine theta over 1 minus cosine theta over sine theta, because once again the cotangent is the reciprocal of tangent and it is equal to sine theta plus cosine theta. So next we will be going to add this. So cosine theta over cosine, since cosine theta minus 1 is cosine theta and 1 minus sine theta is sine theta, let us copy that, over, copy the denominator which is the cosine theta. Likewise, we will also be doing in this side. So it will be written as sine theta over sine theta minus cosine theta. It is over with sine theta, which is the denominator of the fraction. Okay, and it is also must equal to sine theta plus cosine theta. So we ended here. So in this fraction, the denominator is also a fraction. So in order for us to get the answer, we should reciprocate the denominator for us to be able to multiply it on our numerator. So the answer in this, so the answer is cosine squared theta over cosine minus cosine theta minus sine theta. Likewise in this side, sine squared theta over sine theta minus cosine theta. So in this part, what we were going to do here is to do cancellation to get the answer of this. So in this side, we applied the cancellation of cosine theta, so we got the answer of cosine theta over negative sine theta. Likewise on this side, we did the same So sine squared theta over sine theta, we got the answer of sine theta over cosine theta. And we applied the addition. So we got an answer of cosine squared theta minus sine squared theta, because cosine theta times cosine theta is cosine squared theta, and sine theta times negative sine theta is negative sine squared theta over cosine theta minus sine theta. So let us proceed. So for the fourth time, we ended here. So the numerator is a difference of two squares. So we will be going to have an answer of cosine theta plus sine theta times cosine theta minus sine theta over cosine theta minus sine theta. So we will be doing a cancellation again. So we will cancel this, cancel this, cancel this, cancel this, and we are left with cosine theta plus sine theta. And it is true that cosine theta plus sine theta is equal to sine theta plus cosine theta. So that's it. So this is an identity that cosine theta over 1 minus tangent theta plus sine theta over 1 minus cotangent theta is equal to sine theta plus cosine theta, and it is true that this is an identity. And the last but not the least number that we were going to prove is the tan to the power of 4 theta plus tan squared theta must be equal to secant to the power of 4 theta minus secant squared theta. So, tan to the power of 4 theta plus tan squared theta has a common factor, which is tan squared theta. So in order for us to get an answer of tan to the power of 4 theta, we should multiply tan squared theta to itself. Tan squared theta. So, plus 1. Because 1 times tan squared theta is tan squared theta. And it must be equal to secant to the power of 4 theta minus secant squared theta. So, as we all know, that tan squared theta plus 1 is equal to secant squared theta. So we will copy this, the tan squared theta, and then multiply by secant squared theta. Because as what I have said, the tan squared theta plus 1 is equal to secant squared theta. So it must be equal to secant 4 to the power of 4 theta minus secant squared theta. So tan squared theta can also be written as secant squared theta minus 1. Yes. And we will copy this quantity. Squared theta is equal to secant to the power of 4 theta minus secant squared theta. So we will distribute this. So secant squared theta times secant squared theta is equal to secant to the power of 4 theta. And let us distribute negative 1 times secant squared theta. And the answer is secant squared theta. And it is equal to our second identity, which is the secant 4 theta minus secant squared theta. So it is true that this is an identity. That tan to the power of 4 theta plus tan squared theta is equal to secant to the power of 4 theta minus secant squared theta. So this is correct. And that is it, guys. Indeed, math is fun to learn. I hope you learned something. Bye!